Okay, everyone, we're at the allotted start time of our webinar, so we'll get started and I'll begin with a few introductions and a little bit of background. Welcome to the second in our brand new series of CAQDAS webinars, which are organised by the CAQDAS Networking Project, which is based in the Department of Sociology at the University of Surrey. I'm Christina Silva, and I'm joined by my colleague Sarah Bullock, who will be facilitating some discussion as we go. Before we get started with the main part of the webinar, which I know that you're all here for, just wanted to remind you that we do have a few more webinars after today scheduled up till the end of the year. One on facilitating collaborative analysis, one on teaching qualitative data analysis using F4 Analyze, which is a CAQDAS package, and another one about transcription as an analytic act. And as I mentioned earlier, you'll be receiving the link to the recording of this webinar. And you can also access our YouTube playlist and find recordings of other webinars. They'll all be posted there when they're done. I also just wanted to let you know that we're really pleased to be able to be offering some discounts on all of our training courses. So the webinars obviously are free, but we also are running our standard training courses online at the moment. And from now and until further notice, we're providing 20% off all of our training courses for everybody. And if you're a student, whether you're part-time or full-time, and wherever you are in the world, we're offering 40% off all of our training courses. So we're doing that because we're very aware that training budgets are under quite considerable pressure at the moment, and we want to do our best to support researchers and students who are working from home. And that's why we're reducing our prices. So please do have a look at our website. These are the training courses that we have scheduled up until the end of the year, and we will be scheduling some others after Christmas break also. These are the links to our website, and there's also further information about our discounts should you need to find that information out. So let's get on to the main business of why we're all here today. And I have great pleasure in welcoming Dr. Stuart Shulman, who's the founder and CEO of Texifter. And he's based and is speaking today to us from Amherst in Massachusetts. Stu has a very long-standing, prolific and significant history in the field of qualitative methods generally, and specifically in computer-assisted qualitative data analysis. He was an early adopter of CAQDAS for his own research, and he's also invented the Coding Analysis Toolkit, Discovertext and Sifter, and he's going to be talking about some of those today. He was also formerly a political science professor at the University of Massachusetts and director of the Qualitative Data Analysis Program at the University of Pittsburgh and UMass Amherst. And you may be interested to know that as well as his work in computer-assisted qualitative data analysis, Stuart is a soccer coach, something which I know is very close to his heart, and he can also tell you everything that you ever needed to know about garlic. So maybe we might schedule another session for him to share some of those insights with us. So he's keen today to make this session as interactive as possible. So we'll be having a couple of discussions along the way. First of all, after he's given some background, and then later on again. So please do post any questions or comments you have while Stu is talking in the chat at any time. And if you're happy to vocalize your question in the live audio when we have the discussion, then please precede your question with happy. And then we know that we can ask you to turn your audio on and ask your question directly. If you'd rather not speak through the audio, that's absolutely fine. Just post your question without the happy preceding it, and we will collate those questions and ask them of Stu. You are all able to open up your audio at any point, but I think it would be helpful if you turn off your audio now, if you haven't already done so, just to keep things nice and clean so we can hear Stu as he's talking. So without any further pontificating from me, I shall pass over to Dr. Stuart Shulman, who is going to be talking to us today about humans and machines learning together.
Good, thanks for that generous introduction. It's always a pleasure to work with you and the people around you because you're doing the kind of work that I like and I like to support and collaborate on together. So the talk is humans and machines learning together. It'll take about 12 minutes. The slides will move along. They're on an automated timer. I'll have more or less to say about the various things. Christina did ask me to tell a little bit of the story. There is a story here. My undergraduate thesis in 1989 was about two old novels. I was a political science English double major, and I found these 4 pairs of archetypal characters across these 2 books and wrote a 60-page undergraduate thesis about these figures, which included extremist agents of the law, which we see some of today. My dissertation at the end of the 90s used crumbly old newspapers from the farm press, the urban agrarian press, the farm trade papers as well. So I would receive bundles of old crumbly newspapers as a part of doing my dissertation research. I would go through them and very carefully photocopy the articles, and then I would develop a taxonomy inductively using a method most of you will know as grounded theory, whereby I discovered things that I didn't even know I wanted to study by just reading so many news articles and exploring the data in an open-minded way. I had been an organic farmer. As part of my story, I spent a few years between the English PhD program and the political science PhD program growing a lot of garlic. And then when I came back to political science, organized a global conference in 1995 on the politics of sustainable agriculture. So I've been working in an interdisciplinary international way since a grad student day. My work with software began when a US federal government agency gave me 20,000 public comments on a proposed federal rule for what the word organic would mean. I got a grant from the National Science Foundation to use NUDIST, which became in vivo, so that was non-numeric unstructured data, indexing, search, theory building. And they also funded our work bringing together people from federal agencies who had lots of public comments. And in each of these photographs, you also see about 8 or 10 of my students who would go to Washington, D.C. with me to organize these workshops around what to do if you got 1 million public comments and you were a federal agency. In terms of how I understand the world of methods, I was naturally a purist qualitative researcher. I was trained in political science to be a positivist. I kind of resisted, but was exposed to all of that. My real core belief system about text analysis is really down at the purist end. And what I do in practice is pluralist, meaning I do adopt both the positivist and the purist tradition in dealing with text to develop techniques that bring to the surface what I think was perfectly described in the book by Fielding and Lee as all relevant material on a particular topic. Inclusion of potentially relevant material, relevance to a particular position. And so a lot of what I've done and built over the years builds on this core idea you need to be saturated with enough relevant material. And I was also very much influenced by these books by Jarvis and by Weinberger, which suggested a way to scale up what we do and think about taxonomy and classification and search, and especially the Glick book, The Information. It's my favorite book. Highly recommend it. The audiobook is great. And basically, it all boils down to the theory of filtering. And codes and coding and text analytics and qualitative research is really about filtering, where you start with a lot of data and then you work your way to a smaller and smaller pile. And in my work, I had done that using Atlas TI. I had a great sponsorship from the folks at Atlas TI. They put software in our lab. I taught their methods at different universities. And then we built our own extension to do something with the work of multiple coders. It's explained a little bit in the article that I shared with you from 2008. It's just a way of doing something that at the time was not easy to do using qualitative software, which was to compare the work of 2 or more coders to see whether or not when they did something, they would do it the same. And Anyone who's done enough of this work would know that the answer is no. People do the same task in different ways. And so we built this web-based system first as an extension of Atlas, so you could upload multiple Atlas sets, but then it became its kind of own thing, and it grew a little bit, and people were just labeling data inside of CAD. And what we tried to do was to simplify the process of putting 2 or more people to work, labeling the same data sets, and doing the measurements around not only whether they agree, but when they disagree, who was right and who was wrong. And out of that fundamental task, which we call adjudication, we confronted this age-old problem, which is truly inescapable, which is that categories are hard. Some of them are easier than others, but software doesn't remove the fundamental problem that applying categories with humans is difficult. And the software doesn't take away the difficulty. It maybe just helps you understand the landscape of difficulty. So this is a very difficult article to read because a lot of the math is over my head. And I'm a historian and a political scientist, not a mathematician. But the underpinnings of this argument that when you have a lot of data and you have to label it, in groups, that it's important but also difficult to validate the work of multiple labelers working on a task, and that the models that you give coders, taggers, annotators, labelers are inherently wrong, and that there's going to be cases where the model doesn't fit the data or the data doesn't fit the model. And there's no way to get around that the fundamental thing you need to do to apply models in a systematic and scalable way so the machines are actually producing good results is to validate. So when I read this article, the parts I could understand in 2013, it was very important telling me that what we'd been doing in CAT for about 6 years at that point, where we were validating the work of coders, and we were testing models and learning the difference between one that's easy to apply and one that's difficult to apply in ways that were inescapable, especially when starting to try and use crowdsourcing. So a lot of academic research may consider multiple coders to be 2 coders, which is not a crowd, it's not crowdsourcing, and it's not really good for measuring inter-rater reliability, because you really need groups of more like 8 or 10 or 20 people to understand the landscape of agreement or disagreement about a particular label, a particular data set, a particular coder. And because I was getting funded to work with computer scientists, this was basically all they cared about. If you gave a group of coders the same task, would they do it the same way? Would they do it at the same speed? Would they come up with the observations that produced accurate predictions by computers? So this is an illustration of what we do now. It's a part of our software. It's the part where we're doing labeling. The labels are attached to keystrokes. So like 1 would be a first-person expression of fear, and 3 would be not. And the tweet is displayed, and we're able to label it, using just a tap on a keystroke, and then the next thing would load. And the other thing that we developed a real taste for over time was a diversity of tools for sampling. Search, advanced search, filtering on different layers of metadata, filtering on duplicate detection, near duplicate clustering, filtering on machine learning scores. There's all sorts of iterative ways to sample from big data to small data, to the point that when you get to asking people to label the data, you've got a data set that's more relevant to the task than just a generic data set. It's a refined data set. One of the things that has been fundamental to our work is that when we do ask people to do things that are hard, we discover that the task may need to be simplified, or the coder pool may need to be expanded to produce results that are generalizable or defensible. And even in a case where something should be clear-cut, like in this case, where we're labeling a Chinese microblog post, and the task is, does the post refer to the shoot down of MH17, an airliner? And it clearly did, and 4 out of 5 coders said it did, but 1 said it didn't. And adjudication simply means, in this case, we would say coder 2279 got it wrong, the other 4 coders got it right, and we would keep track of that over time. That gives us the ability over time to rate individual human annotators on the likelihood that they'll produce an accurate observation. And so fundamental to my thinking about all of this is that not all humans are created equal. Not everybody can code every data set. Not everybody is good at coding at all. that there's a lot of variation depending on the difficulty of the task. And our idea for enhanced machine learning involves finding those human observers for a particular task who are most likely to produce a valid observation. So this is an example of coder rank in action. Each of these humans has labeled a certain number of items. We've adjudicated a certain set of them. And over time, we've seen that even amongst very good annotators, there's a difference between the first and the ninth, a pretty significant difference. Even though I would say all of these annotators, if you're right 88% of the time, you're doing pretty well in coding. But in this case, for this task, coder 9 was the least good and would be ranked lower. So what we do is we go back and forth between having humans create training sets and then using those training sets to train the machines, often in binaries because they work better for machine learning than non-binary classification schemes. It's easier to get a working model out of a binary. And then we do a lot of word sense disambiguation. So if you want to study smoking on Twitter, you have to get rid of the weed. You have to get rid of the barbecue. You have to get rid of smoking hot boys and girls. If you want to study a company in social data, you have to get rid of the towns with the same name, the theaters with the same name, the actors or the characters with the same name. If you want to study patriotism in American politics and patriots, which are often violent militias right now, you got to get rid of the football, which is a different kind of organized violence. So what do we contribute to this space? It's a web-based tool. It has certain techniques for measurement innovation that we think are fairly unique. It supports the real-time, easy collection of Twitter data from an open API. We have various ways of creating samples and support keystroke coding in groups using specialized search and filtering techniques. The ability for non-computer scientists to create custom machine learning classifiers, to do things like word sense disambiguation. I think there's no actual other product in the world that does that the way we do it. So I would say that's probably our biggest and best contribution to the field. And thank you for listening. I'd be happy to answer any questions before we do the demo.
Thank you so much for that, Stuart. I've really enjoyed that. Haven't heard you speak about the tool for a little while, so thanks so much for that. It's got me thinking about lots of things. I have a question based on my own experience as a coder.
Okay.
And it's to do with the fact that, so you're speaking about variation between coders and ranking coders. I also find that in my own experience, there's even variation in the quality of my own coding.
Yes.
Over time. And did you have anything to say about that? Does the tool take account of this? Have you thought about that sort of thing?
So the tools can only do what, the functionality that is non-human, right? It can record a human action, but the tools are just the tools. So what you're describing is like the evolution of a human, which is a very important part of this. I often say to new annotators that you're a different person. If you have to label 100 items, it's the first time you've done a task. You're a different person on item 50 through 100 than you were on item 1 through 10, because you've been shaped by the data. Anybody who's done any kind of inductive qualitative work knows that the journey to who you are at the end of the project involves many stops and twists and turns along the way, and can be quite unpredictable. And so I would say that it's natural and a good sign that you're aware of that evolution, because it shows that the data is shaping your understanding of what's going on. And I think it's a good thing. Is there a way to measure it? Well, one way I've noticed over time is that if you don't, especially when we work with Twitter data, if you don't deduplicate the data or the BIOS or whatever it is we're coding, you may have to label the same item multiple times in a set of 100 or 200 or 500, and you may not be able to remember, or I blame that on age, or it may be that in the 20 or 30 or 50 intervening observations, you've changed your mind, right? Yeah. And all of those things are normal and natural, and all the more reason to have lots of short iterations of how you test the coding and the interpreting and the analysis before you make a high wager that you've figured everything out.
Yep. Yep. Thank you. Christina, you had a question as well. Do you want to ask Stu about the question that you had posed?
Yeah, thanks, Sarah. So, Stu, you were talking a lot about consistency in coding, validating and producing accurate codings. So what would you say to those who might argue that in a qualitative analysis, the differences that multiple analysts bring to the process is actually what we're interested in, what they value as you know, the kind of qualitative end of that spectrum that you brought up before?
Yeah, no, I would absolutely endorse that as the best case, the best argument for crowdsourcing. The more people you bring, the more diverse people you bring to a data set, not only the more ground you can cover, but also the more unique reflections you may get. So when we have unstructured analysis of open-ended data, for example, we were looking at Black Twitter and trying to figure out when Black means Black, we, at the end or even during every session of reviewing, you know, tens or hundreds of user bios on Twitter that have Black in them, we're writing memos. And those memos are, you know, shared documents, usually a Google Doc or some kind of shared document, where you can see in real time the evolution of what's happening. So I would absolutely say that the ability to do certain things like measurement, machine learning, coder rank, in no way undermines or invalidates the proper role of good qualitative, inductive, contested research. They're not, it's never an either or, they're always mutually reinforcing.
So that means that the more people you have involved in that process, then the more you can be confident that those decisions, those in terms of accurate codings, are taking account of all of those different perspectives.
Well, again, it depends what you mean by accurate, and
yeah,
accurate in one sense, the one I think we're discussing, might be authentic, right? Where authentic means it's someone from the community being studied, not an outsider. They have an interpretation of the language, the discourse, the embeddedness of the language of the discourse in the context of the culture that's rooted in their own identity. It's authentic. Could any person from the outside come in and create an observation, record an observation as authentic as that? That's a philosophical debate. So
thank you.
You're welcome.
Thank you. We have we could probably take up a bit more time on a few questions that we have for you, Stuart, but we'll give the rest of the attendees a chance as well. So if you're happy to proceed to the demonstration side of things, I'll also invite everyone here just to make use of the chat function and enter some questions in that you might have for Stuart. Remember what Christina said earlier on, if you're happy to kind of vocalize your question to Stuart at the end of the demo, then prefix your chat question with the word happy, and otherwise you can just leave it in textual format without the word happy in front of it, and I will either read it out for you, or Stuart can answer it after the webinar is finished in textual format under the video. So are you okay to progress there, Stuart?
Absolutely. I had put a mute on because there was a low-flying airplane. I was afraid that was all you would be hearing.
Sorry to interrupt, Stu. Before you do that, there is one question in the chat now from Dana. Do you want to ask that question?
Hi. Yeah, can you hear me?
We can.
Yes.
Perfect. Hi, Dr. Shulman. This is great. I'm just kind of wondering if you could have you used these techniques with dyadic data. I'm just curious because I do a lot of health communication, so between family caregivers and patients, and providers and patients. I'm just curious if there are ways we can think about using these techniques with dyadic data.
So I just want to make sure I understand exactly what you mean by dyadic. You're talking about like an interview where it's going back and forth between a pair of speakers or something like that?
Yep.
So I would say in many cases that the Discovertext and the Coding Analysis Toolkit, although they've been used for that kind of data, are not built for that kind of data. In the sense that some of the features that I was accentuating in the presentation about the speed at which you can label large numbers of items presupposes that the large number of items are formatted where you can look at one or maybe one. We do have a feature where you can see the one before and one after it, but where it's a pre-formatted span of text. Whereas in Atlas or in Vivo or the other QDA packages, you might click and drag and release and highlight a span of text in a longer interview transcript or focus group. I have never really argued that those kinds of data are amenable to analysis, even though people do find ways to get it into our system. I actually think other people's software is better for that kind of data. Does that make
Thank
sense?
you.
Just because
Yes,
it's because of the contextual nature and the fact that in the kind of data you're describing, you can't really predict how long somebody's going to go on. So do you break it into sentences? Do you break it into paragraphs, multiple paragraphs? That's a judgment that a qualitative researcher makes using a mouse. And part of the underlying philosophy of our software is to get the mouse out of it as much as possible.
Gotcha. Thank you.
Thanks for the question. Are there any other questions?
Not at the moment. Thank you for that question, Dana.
All right. So are you able to see my screen now?
Yep.
Yep.
It looks like Discovertext in the Discovertext homepage.
Yep.
Okay. So I'm just going to show you some of the basic functionality of the system, and again, invite any questions along the way. I've got some existing projects here. We can poke in on one I started just this morning. But I wanted to show you how, if you were starting from scratch, is there a topic anybody is willing to share that they're interested in that might be discussed on Twitter these days? We use Twitter as a demo here, but I will talk about the other types of data that can be uploaded.
This is Najim Abbas.
Hello.
Hello. A question could be how future education is being discussed on Twitter. Is it hybrid education? Is it new form of education? So
Sure.
Are there people who are researching what COVID has changed in the sphere of education?
So COVID and education, yeah, I've got some big data sets on COVID that are not fully explored yet. So I just started a new project. I've given it a name, Education. Thank you for the suggestion. I appreciate that. Just to explain a little bit the way the system is set up, there's some functionality for management here. There's various feature sets behind these, I guess, expandable menus. And some of those same functionalities are often available here on the main screen. So this is a blank new project. All it has is a name. And the three major types of artifacts in a Discovertext project would be archives, which are raw data. And I'll show you how to start an archive in a second. And then there's buckets, which are subsets of raw data. So you might think of search results or filter results or coding results or machine learning results going into a bucket where you've basically taken a bigger collection of raw data and reduced it to a smaller subset. And then the third level of every project are data sets. And data sets can be buckets or archives that have been converted into data sets for coding by humans. And so those three levels are important because they basically consist of raw data, subsets of raw data, and data that you have structured in a particular way to do a certain style of coding. And I'll talk about the various styles of coding we support. Over here is the gray button, Import Data. So to start a new project, you have to bring data in. I mentioned I would talk about some of the other data types. You can upload a plain text file where every unit of text is just separated by a blank line. That is one way to bring data into Discovertext that is highly amenable to most data, as long as you're able to structure it so that there's a chunk of text, a blank line, a chunk of text. You can just generally upload that very easily. Another very common way to upload data is in a spreadsheet, and this may look like a lot of survey data, right? So if you've done a survey and you've got survey responses that have a mix of qualitative and quantitative or structured data, you can just upload that as a CSV file. For the demo today, I'm going to show you how we collect Twitter data using something called the Twitter Search API, which requires that you have a Twitter account. I've actually already logged in earlier, so I'm logged in. If I hadn't logged in earlier, I would have been required to give a Twitter username and to tell Twitter it's okay to use my token to start a new project. And the topic here is education and also COVID, which I think is a great idea for a demo. So I'm just giving the repository a name. Remember, an archive is just going to be a collection of data. And this one's going to be called education space COVID. And then here I can enter my query, right? And I will point you to this link here. If you're doing social data for the first time, it's to documentation from Twitter about the kinds of things you can put in this box. I'm not going to go through all of them today. There's a lot of variation. For today, we're going to make a very simple education blank space COVID. So this is technically a query going to Twitter under my name saying, I would like to collect data that matches on these terms. On the next step, which is the last one, you'll have a number here, like 100. And you can set the frequency of the query. You can go once a week, once a day, twice a day, 4 times a day. The default is once an hour. And what that means is it's going to go to Twitter and say, will you please give us some data every hour for the next 100 hours? And this is the start of the data coming in. So this is our first archive in a new project. And we're looking at data related to education and COVID. You can go in and see some of the properties of Discovertext that are available. So far, 33 items have come back. If I want to just go in and see what kind of data is responsive to that query, education, blank space, COVID, then I can go in and begin to review the data manually. And again, my roots are in qualitative, so I can look at it in the list view, see, oh, there's a bunch of retweets, people talking about various things. I can go in and look at the individual items, and data will continue to flow into the system as the review is going on. So that fetch that we set up for education, blank space, COVID is still pulling in more data as we go. And when we go in and look at an individual item, we see it in the Twitter display, right? And we can actually go just start browsing through to get an idea of what sorts of data is responsive to that particular query. Let me just stop for a second and ask if anybody has any questions about what they just saw.
We don't have any questions from the attendees at the moment. I have a question, though, briefly. I don't want to jump the gun too much, but you were talking about tweets and others are retweets. Is there?
Sorry, just lost your audio there, right in the middle of the question. Could you repeat it?
I think Sarah's having some connectivity problems.
I'm going to guess what the question was.
Yeah.
Sorry.
Oh, there
you lost me there for a moment, didn't you?
Yes.
Yeah, apologies. We're always managing these sorts of things these days, aren't we? So I was just interested in finding out whether you're able to track tweets and retweets. So you discussed that some of them are tweets and some of them are retweets. Is it possible to trace them in a sort of a conversation?
Yes, and there are different ways of doing that. Sometimes the best way of doing that is actually on Twitter itself, looking at it live on Twitter. So one of the things you might have noticed is when we were looking at the individual tweets, we were looking at them in the Twitter display. And I think that's an important point that I'd just like to stress, that if you're new to this, there is a fundamental difference between looking at spreadsheet of tweets, which is the way I would think that maybe 99.9% of academics study Twitter, and looking at it in the live display. The live display is the legal way to do it, right? Because if any of those tweets have been deleted, they won't show up because they're in the live display. You'll just see that a tweet has been deleted or the account has been suspended or whatever the case may be. By the way, in this small set, these are the most common retweets, right? 58 of this tweet.
Okay.
8 of this one, and 6 and 5 and 4. As it gets bigger, you know, you can. There are probably more ways to slice and dice this data that we could possibly show. Right? So like that was done with 250. Now we're up to 400. You know, an hour from now or 2 hours from now, there'll be quite a bit more data. So this is just sort of the first drops coming in from a very short period of time, which looks like about an hour's worth of data. Which also allows you to assess sort of what's out there, what's available. Again, thank you for the suggestion, education and COVID. If I had just put COVID, the amount of data would be much, much greater, right? Because by adding the requirement that you see the co-occurrence of 2 terms would greatly reduce what comes back. I just want to show you a few features of the data that people often ask about, and things that I work with all the time. So this is Twitter metadata. So in this collection, so far, the top hashtag is COVID-19, then COVID, then COVID, then education. If I wanted the whole list, I could download it here. You can see the top users. If I'm interested in user descriptions, a lot of my work centers around user descriptions. This is how we get them. We create a collection and then just download. It's a legal download to extract a part of the data, in this case the description or the location, whatever the case may be, for analysis in third-party software. Or sometimes I just download these user descriptions and I upload them as a spreadsheet back into Discovertext for building models about users. So that is something we call the top meta explorer. It's just a way, if you have surveys, it's a way of filtering the data so that you can look at a subset that might use any one of those metadata fields or combinations of those metadata fields. And again, all of these features apply to non-Twitter data as long as you have structured metadata to create very specific samples. So say you have a survey and there are various questions where they've got rating on a scale of 1 to 3 or 1 to 5 or 1 to 10, whatever the scale may be, and you want to break down subsets of what people who give different answers on the scales are saying about things. That's the way you could combine a structured filter with an unstructured text analysis approach. A lot of people like this. It's just lists of terms that are frequent. These are the single terms. I don't consider these results. In large part, what you see here is the result of virality, right? There probably weren't 64 different people who wrote ID speak in a tweet. It's much more likely that that's one of the viral, those a common term in one of the viral tweets. So this does give you a little window into within this collection what the frequent single terms, bigrams, trigrams would be. If I wanted a more accurate rendering, I might take a sample of one of all the groups, one of all the ones that aren't in groups, and then look at the term frequency. It would be more representative of the diversity of the data rather than the virality of the data. Let me go to this other project I created specifically to show you about some of the trade-offs here.
We have one quick question. Is
Sure.
that okay, Stuart?
Of course.
Yeah, so
I'd love to stop talking.
The question is to do with accessing Twitter data, I think, and it reads: is a Twitter account sufficient to access and analyze such data, or does it require other forms of authorization?
To do the kinds of things I'm doing just requires that you have a valid Twitter account. So when I was doing more of this research, I actually had more Twitter accounts, notorious people who break the rules and have hundreds or thousands of Twitter accounts, and that's a whole separate story and a problem. But to do the kinds of things that I was demonstrating here today, you would just have to have one Twitter account, and you would go through a credential, kind of like when you use Twitter or Facebook or LinkedIn to log into any other software or platform or cloud service. You're basically using your credential, third-party credential from Twitter, to authorize the action. And there are certain things that are allowed. So for example, these two collections here, this one has 16,000 tweets, this one has 11,000. I started this project just this morning. So this is like an hour old. In the first one, I queried for Ohio or OH, which is the abbreviation, or Florida or FL. And I ended up getting a bunch of data that had the word O in it. And, process of elimination realized you can't just put OH and hope to get all the Ohio data off of Twitter, because you're going to actually get the most viral tweets that have the expression O in them, which come from all over the world and may have nothing whatsoever to do with what it is you're studying. So a big part of what we teach people, regardless of whether it's Twitter data or any other medium scale or large scale text data set, is that when you have a bunch of data, the first step is usually cleaning it. And by cleaning, like here we see examples, right, of Oh My Cafe, which was a viral tweet. And so I'm not getting Ohio here. I'm getting data that I'm not interested in. And I looked at this and I said, oh no, what we really need is to just query against the word Ohio or the word Florida, and that will eliminate a bunch of this data that is not what I want.
So sorry, can I just clarify, when you say viral tweet, do you mean, this is a question also that Anne Lewins posted earlier, to do with duplication. Virality in this instance is tweets that are duplicated by bots? Is that what you're...
No, virality, well, virality has multiple parents, right? If you're Justin Bieber and you're caught, smoking a cigarette when he was a young kid, and 2 million people retweet it, some percentage of those are people, and some percentage of those were bots, and some, there are all sorts of reasons why it might happen. But so when we say viral, we don't mean inauthentic. We instead mean that, like in this case, when I ran this, I guess just before the webinar, there were just over 4,500 tweets at the time. This was the most viral tweet. Now it's retweets of Joe Biden. So, there could be some bots in there. I've heard of Democratic bots. You're much more likely to see a Donald Trump tweet go viral because of inauthentic behavior. I just completed a 2-day workshop with the researchers on inauthentic behavior with the NSF, and there's plenty of it. It goes on all the time. But some of these people are celebrities. So no matter what they tweet, some portion of the number of times that they get retweeted is going to be authentic and some isn't. So here's the second one on this list is Eric Trump. Right? He's the son of the president. It's very likely that he pays an army of people to retweet his stuff. And third-party firms. I mean, I've done a whole presentation on to the intelligence community on inauthentic amplification of Twitter data in elections in the context of hunting bots and trolls. There is certainly a huge drawback to using Twitter data. Is some of it, this is the tweet that went viral, comes from people who are real. Like this person's screen name is amazing. If I want to go authenticate amazing, amazing, who happens to claim to be in London, you know, does this look like an authentic human to you? This is sort of what's involved in sort of hunting for bots and trolls, is like, who are the 18 people who follow amazing, amazing? Uh-oh. This is 3 stars for General Flynn. 3 stars for General Flynn. I can tell you right now, these are probably bots and trolls.
Okay.
Without a doubt, by just, a couple of clicks from, sorry, I got to get out of Twitter now, from looking at a single tweet that was one of those viral retweets, I can pretty much, based on my work in this field, guess that amazing, amazing is either a fake human or a bot, probably a fake human, a troll. Could be someone anywhere in the world being paid to retweet Eric Trump per click.
Okay.
Here's
Thank you for that. Sorry, I
Great
keep
question,
interjecting.
actually. Sometimes you start looking at these long lists of followers and following and Twitter accounts. It can become a little bit of a bottomless pit, because they're in some cases you're constantly finding things that cause you to question what it is you're looking at and why it exists. Some of it is perfectly obvious, real people talking about things. I think it's much easier to study things like how people deal with illness or a disease or the COVID, for example, than politics, because the likelihood of an orchestrated or campaign around how you deal with diabetes or some other condition is much less likely than an orchestrated campaign to topple Western democracies, which is ongoing and well documented in its scope and reach. So it depends what you're studying, whether you're going to see authentic or inauthentic posting.
Thank you very much for clarifying that. I won't interrupt you any further and just let you get on with showing us a little bit about.
I was really hoping for another interruption, actually. Are there no more interruptions?
There are no more interruptions at the moment. We're keen to see some of the coding and adjudicating. Thank you so much.
Okay, let's go back to education and COVID, because I think it's a good example of how there might be more authentic data. Of course, there's hucksters and people selling snake oil solutions or promoting this or that. There are all these ways in which Twitter is a giant conveyor belt for all sorts of authentic but not helpful behavior. As we all know, not all humans play nicely or behave well when they're in a big sandbox like this, and that's what Twitter is a big giant sandbox. So let's go back to some features. We're up to 1,869 tweets. One of my favorite features across all of the tools in Discovertext, and I use it in every project all the time, is search. So that's a simple text search. It could be a search through a metadata field, or it could be a search through the text of the body of the data. So for example, if I wanted to see how COVID was appearing in the body of these 1,892 tweets, the simplest of searches leads you to a kind of inductive methodology, right? Because search results, when you see them in a list with the search term highlighted, allow you to sort of let the data wash over you a little bit and start to understand the context in which people are referring to COVID in these tweets that are responsive to the query that was suggested on education and COVID. So this is the first search through new archive, so it's indexing, but the term COVID actually appears in the body of only about half of the tweets so far. So that might mean that the match COVID education is a combination, which in Twitter, between matching like this one in the body of the tweet, or it could be a match between, in terms of how it came to us from Twitter, that the word education is in the metadata rather than the tweet itself. So I like to sometimes make my list very long. This is a web browser, so the longer you make the list, the slower it's going to load. But I'm often willing, to take a sip or two of my coffee while I wait for 1,000 items in a list to load, which will take a second, and then I can run my eyes over them. It can be quite not just sobering, but also informative, because one of the key things that I always assume is that whatever strategy I've adopted is not quite the right one. That there's something I'm going to learn inductively from looking at lots of examples of samples that will cause me to adjust either how I collect the data or how I begin to break it down and sample it and the criteria that I use. Sorry, this is taking a little longer than I'd hoped, but the main idea here is to say that I think when I especially work with graduate students who have to, prepare a defensible plan, strategy for how they're going to execute their thesis, I'm sometimes concerned they haven't spent enough time with the data yet to really understand its landscape. I use that term a lot, but the landscape of the data. So here's a list of, now 994 tweets that are out of our collection of almost 2,000, and I can run my eyes over them, see the role of emoji, not very prominent in this collection, can see the relative likelihood of a retweet versus an original tweet in some cases. I can see co-occurring terms, and if I want, I can put these search results into a bucket. Right? So again, the original filter was the one suggested by the participant, education and COVID as a query against Twitter. And now a secondary filter is that we've done a search and we've taken a subset of those items and we'll put them into a bucket. And again, a bucket is just a subset. So you can think of it as a folder, or it doesn't change the underlying raw data in the collection. It creates a subset, which is actually, by the time we did it, just over 1,000. And now I may want to do some of those features, some of those sampling features that we were looking at before, such as exploring the metadata, the term frequency, or, I know we should have talked about it earlier, creating a data set to code, but let's just do it now as the last thing. It is hard to squeeze all these features into an hour. It's usually a day or two to cover all of them, but we're doing the best we can here. So here's a process by which a sample is created. Let me make the screen a little smaller. I may want to take a random sample out of my bucket. So say I'm going to take 100 items. It's 9% of my bucket. I may want to filter out items that are already in other data sets. That's a very useful tool. I may want to choose from an existing code set. I've got many that I've built over the years. Or I may want to create a new code set if I'm a new user, first-time user. And then there are various options. And they boil down to 4 tracks. Right? If you're doing grounded theory, inductive work, that's what we call user-defined codes. You're making your codes up as you go along. You're either an individual or a group, and you're going to label these 100 items, and you're going to develop your code list inductively. If you know your codes, then it's a matter of just leaving the default and deciding whether or not to restrict the coder to picking the winner or picking from the available codes. And then we have a much more complicated, impossible to explain way of creating very complex hierarchical 4-level code sets. I never do it. I can't stand it. And I know we're close to time, so what I'm going to do just for today is show you a very quick one of how you can set up some codes and do some labeling, and this code set would become a reusable code set. So it might be relevant to my study or not relevant. You might want to have a 3rd or 4th or a 5th or a 10th category. I do a lot of relevance coding. And essentially, this is now, if you think about the steps we took, we grabbed about 2,000 tweets, education, COVID. We searched for COVID. That gave us about 1,000 tweets. We took a random sample of 100. We created 2 codes. And now we want to label. We want to label whether or not these 100 items are relevant to the study. And this would be the first step in engaging the data directly, right? I might see this, yes, it's relevant. I hit the keystroke 1, and the next item will load. And this is, I think, the unique part of Discovertext is the fact that we've tried to streamline the way in which, this is tweets, but again, these could be open ends on surveys. There could be other kinds of short bits of structured text. But this is labeling as we do it. There are other ways to do labeling, but essentially this is the building block of a machine learning model on whether or not this data is relevant to a particular study about education and COVID.
If you allow me, Stu, this is Najm again.
Hi.
Hi. For example, if I say I don't need anything about preschool or school level, I only need to know about higher education affected by COVID.
Absolutely. So the scope of what you collect from a public data API is up to you. And in my, we chose 2 terms, education and COVID, but you could have included a more complex rule that would restrict what is responsive to matching all of the requirements of that rule. And the trade-off is, as with any method, the more restrictive and complex the rule, the fewer observations or the fewer data items you're going to have to look at. And so I usually over-collect data, and then I work my way back. And if I discover along the way that there was a better way to collect, like for example, in the Ohio-Florida example, eliminating OH made a much cleaner data set than having Ohio or OH. And so those are things you learn through what I described in the slides as that iterative engagement with the data. You come to the data with a broad brush, and through engagement, whether it's inductive or deductive, structured or unstructured, you gradually refine your approach where you're more cognizant of what's possible, like the original question, which was a good one, about how you evolve as an annotator when you're exposed to more data. I really counsel and coach an open mind to students and practitioners to not think they know the data until they've spent a good amount of time with it. It always can teach you new things about the trade-offs of going broad and wide versus narrow. For example, so many colloquialisms are relevant to so many topics of study. And if you leave the colloquialisms out and only use the formalisms, you're going to miss maybe a big chunk, an important chunk of the data. And
thank you. I'm so sorry, I have to interrupt you.
One last example. To study suicide, we don't look for people who write, "I feel like committing suicide." We look for people who feel hopeless or helpless or that their life is out of control, right? Because the message or the signal is not that, "Hey world, I'm going to kill myself." It's other things. Sorry, I didn't mean to talk over.
It's okay, and it's an excellent way of ending in so far as it brings us right back to the roots of the qualitative data and of our job as qualitative data analysts to remember that context and remember how words are placed in context always. Stu, I thank you so much. I'm going to pass back to Christina now, if that's okay with you, because we have run out of time.
Of course. My dogs are also telling me that we've run out of time.
Christina, over to you.
Hi, thank you. Thanks so much, Stu. Just to echo Sarah's comments, I found that really fascinating. There's so much more to talk about, and I'm just going to take control back over. Hopefully you can all now see my last slide, but you may have noticed that at the top right of the Discovertext interface when Stu was talking, that there's a nice button there which will allow you to ask Stu for a demo. I think you're still doing those demos, is that right, Stuart? So if people are interested in seeing and hearing more, then they can contact you that way.
There are regular demos.
There are regular demos.
They happen all the time. People can sign up at their leisure, and talk about a specific research problem. Doesn't always result in people using the software, but I think it does help people think through some of the problems. So I'm happy to do it.
Great. Okay, thank you so much again, just on behalf of everybody. There's lots of thanks coming through in the chat as well. We hope that you all enjoyed that discussion and demo.